Now, in the new segment, what are we going to learn? We learn various properties of addition and subtraction of integers. Now you are thorough about that. So there are certain properties, and the first property is closure under addition. Before starting to explain this property, let me introduce a story to you. Suppose if there are, I take a bag, right, and with the numbers inside it, all the whole numbers are kept in that, right? Or if I put in all the integers in that, let there be all the integers. So if I take any two integers out of the bag, if I take the number 1, yes, it's an integer. If I take another number from the bag, that is suppose number 8. And if I add them together, 1 plus 8, what is the result? You know the result is 9. So will I be able to find that 9 also in the bag? Yes, because that bag contained all the integers in it. So that means I can say, if I am taking any two integers and I am adding them, I will also find the result present in the bag also. That means the bag is closed under addition. If I take any two integers from the bag and if I do subtraction, like if I take the number 1 and if I take the number 3 from it and if I subtract. So if I do 3 minus 1, I'll get the result as 2. Okay, and 2 will also be present in the bag. But what if I do 1 minus 3? If I do 1 minus 3, they are opposite sign. 1 is a positive, minus 3. 3 is now a negative number, right? 1 minus 3. The result you will get is minus 2. And will minus 2 be present in that bag? Yes, of course it will also be present in that integers bag, because integer bag contains all the positive number, it contains all the negative numbers also, even it contains integer. So yes, that's true that we will find up all the integers. If we add them together, if we subtract them together, we will find the integers present in the bag. That means it is closed, that bag is closed under addition and under subtraction. So to summarize, we can say the sum of two integers is also an integer. That is, if a and b are two integers, then a plus b is also an integer. This is the closure property under addition. So you see, if 5 plus 2, yes, we are having 5 an integer, 2 as an integer, and 7. The result will also be present in that bag of integers. So 7 is also an integer. Similarly, minus 6 plus 2, the result is minus 4. Look here, they are opposite in sign, so they get subtracted and we put the sign of the bigger number. So the result is minus 4 and it is also an integer. Similarly, 4 and minus 3, the result is 1 and 1 is also an integer. So you find out like minus 4 plus 3, the result minus 1 is also an integer. And also minus 4 plus minus 3, the result minus 7 is also an integer. So we can simply say that it is closed for addition, or it is closed under addition. Now let's check out for closure under subtraction. We have already discussed, if we subtract any two integers like a minus b, the result will always be an integer. It may be a positive integer or it may be a negative, but yes, the result will always be an integer. So to summarize, if a and b are two integers, then their difference a minus b is also an integer. Just this is closure property for subtraction. Now the next property that we do is commutative property. And again we have commutative property of addition or commutative property of subtraction. Let us check it. Is it for multiplication, for division also? We'll go it in detail. So here commutative property of addition, what does it say? It says that the sum of two integers remain unchanged even if the places are interchanged. In other words, if a and b are any two integers, then what happened? We can say a plus b or b plus a. The result will be same. Whether you are adding b to the number a or you are adding a to the number b, the result will same. That means you can change the order of the addends. Addends are the numbers which you are adding or the integers which you are adding, right? So you can add them in any order. For example, if I take the number 13 and minus 6, if I am adding 13 to minus 6, see, or if I add minus 6 to 13, will I get the same result in both the ways? See, here I am getting 13 plus minus 6, or I am changing the order. I am writing minus 6 plus 13. The result will be same. 13 minus 6 is 7, and even minus 6 plus 13. They are opposite in signs, so they will fight with each other and get subtracted. So 13 minus 6 is 7, and since 13 is the bigger number, so the final answer will also be positive. So result in both the cases will be positive 7. Also, we can see one more example, minus 20 plus 10, or if I write 10 plus minus 20. But remember here, when we are changing the order, we are not changing the sign. Here, when we are taking a term, if I want to shift any term here, like minus 20, so I will add minus 20. I am not changing the sign of 20. This 10 is already positive, so I have written 10 previously, and minus 20 will be written after that. So when we are adding these two things, what happens? Adding a negative number. So adding a negative number means subtracting that number. Again, 10 here is positive, 20 here is negative. When two numbers of opposite signs are added together, they will fight and they will get subtracted. So we get 20 minus 10. So 20 minus 10, the result is 10. And what is the sign of the bigger number? The bigger number is 20, and the sign of 20 is negative. So here you will get the result as negative 10. Okay, so this is commutative property of addition. That means you can arrange them in any order and can add the numbers, add the integers. Let's see, is it true for subtraction? So it does not hold true for subtraction. Reason? Let's take with an example, 5 minus 2. We have the number 5 minus 2, and 5 minus 2, the result is, we know that it is 3. The result here will be 3. So we can say 3 is not equal to 2 minus 5. What is the result of 2 minus 5? Again opposite signs, they get subtracted. The result is 3, but 5 is the bigger number and it is negative here. So the result is minus 3. We get here 3 and minus 3. They are not equal to each other. So this is a very important thing, that commutative property, it does not hold true. That means we can say A minus B is not equal to B minus A. We can only add them in any order, but we cannot subtract them in any order. Order has to be fixed if there is subtraction in that case. Let us check, is it true for multiplication also? Likewise, it is true for addition, but does not hold true for subtraction. So is it true for multiplication? If suppose I multiply any two numbers, for example, 2 times 3, and if I multiply 3 times 2, will the result be same in the case? Yes, I'll get the result 6 here, and here also I'm getting the result 6. So I can say I can multiply them in any order. I can add them in any order. Similarly, I can multiply the numbers in any order. So we can say that commutative property holds true for addition and for multiplication, but not true for subtraction. Does it also hold for division? Let's see. If I divide 4 by 2, I get the number 2 here. 4 divided by 2 is 2. And what if I divide 2 by 4? 2 divided by 4. You can also write it as 2 over 4. And if I cancel, if I reduce it to the lowest form, I get the number 1 over 2. That means 4 upon 2 or 4 divided by 2, the result was 2. But if I divide 2 by 4, the result is 1 over 2. So in both the cases, the result is not same. So commutative property does not hold true for division also. That means A divided by B is not equal to B divided by A. Very important thing. So two properties for which the commutative property holds is A times B is B times A. That means it holds true for addition and multiplication, but does not hold true for subtraction and division in this case. Now let us move to the new property, that is associative property. And associative property of addition, it is just as similar to the commutative property, but in an extended version we can say. In commutative property, we dealt only with two integers, but here there may be more than two integers as well. That means if the sum of two or more integers remain unchanged, even if their places are interchanged. In other words, if we say a, b and c are three integers, then we can say a plus b plus c is equal to a plus b plus c. Now you can see both the things are written almost in a similar way, but the only difference here is the places of brackets, the positions of the brackets. In first part, here I have just kept the bracket on b plus c, and here I put the bracket on a plus b. So we can understand it with an example here. Let's see 6 plus 2 plus minus 5. That means first, if I am doing, what is the importance here for placing the brackets? Let's see. If it is a big bracket, that means if I am adding 6 plus 2 first, the result will be 8. And then I am adding negative 5 to it. So 8 plus negative 5, again they are opposite in sign, 8 is positive and 5 is negative. So they get subtracted, we get 8 minus 5, the result is 3, and the sign of 8 is positive, so the sign of 3 is also positive. Now let us see what if I made another pair, okay, that is rearrangement. Now instead of doing 6 plus 2 first, let me do 2 plus minus 5. Let me add minus 5 to the integer 2. So again they are of opposite signs, that shows I'll subtract the number 5 minus 2, the result is 3, but 5 is bigger and it is of negative sign, so I'll get minus 3. So I'll write it in the manner 2 minus 5 and I'll get the result as minus 3. So I will add minus 3 to 6. Again 6 and minus 3 are opposite in sign, so they'll fight, they'll subtract, and we put the sign of the bigger number. So 3. That means it does not matter which number you are adding first, which pairs you are making. That means you can first add b and c and then you can add the result to a, or you can add first a and b as you have done here, and then you can add the result to the number c. The result will remain the same in both the cases. I hope this addition property of the associative property of addition is clear to you. Now let me take the associative property of addition, one more example to it. Suppose there are three integers and all three are negative. Now what can be done? What can be done in this case? First we will add these two integers, minus 3 and minus 2, on a number line. So here we can relate how you can check it through a number line also. So here first we are doing minus 3 plus minus 2. What is the result? Minus 5, we already reached from 0 to minus 5. So here you can see from 0, first I'll reach to minus 5 and then I'll do minus 3 plus minus 2, adding them together. So what you will get? Minus 2 and you will get minus 5. That means you are moving 5 steps back. So you reached the result negative 10. But second thing, when you are doing it, first you are making a pair of minus 5 and minus 3. That means if you are doing this step first, so what you will get? First you will reach to minus 8 and then from minus 8, again what you have to do, you are adding negative 2. That means as we have done it here in this case, we are adding negative 2 to the number. So we can simply move negative 2 steps to the left. But in both the cases, you will be reaching to the same result, minus 10 and minus 10 in both the cases. So you can check it through the number line property also. Now let us move on to the next segment, additive identity. What do you understand by additive identity of any element? It means when we add 0 to any whole number, we get the same whole number, right? For example, if we say, if I take the number a and if I add negative a to it, then what will be the result? The result will be 0. Or in same way I can say if I add a to negative a, the result will again be 0. That means if the number to which additive property of 0 is also called as the existence of additive identity. Let me explain it in detail with an example. Like 6 plus minus 6 is 0. So number which when added does not change the identity of that number. That means if to any number, suppose let me take an example here, 2. Okay, so I can say if I take the number 2 and if I add 0 to it, right, what will be the result? The result will be 2 only. That means when I am adding 0 to a number, the identity of the number is not changing. So what is the additive identity here? Additive identity of any number is 0, because this is the only number which does not change the identity of any number. In other words, we can also say this thing, that if I add negative of a number to that number, that means if to a I am adding negative a. For example, if to 6 I add negative 6, I get the result 0. Okay, so I am getting the identity element, that is 0. I am getting the additive identity element 0. And what are 6 and minus 6 to each other? They are additive inverse of each other. Don't be confused between the two words, additive identity and additive inverse. Additive identity is always 0 for any element, whatever it is. But additive inverse of a number is the negative of that number. Means if I am talking about the number 6, its additive inverse will be negative 6. If I am talking about the negative 6, then its additive inverse will be the number 6. And when I add a number and its additive inverse, I should get an additive identity, that is 0. So when I am talking about additive identity, that means I am talking about the number 0. So we can say additive property of 0 is also called as the existence of additive identity. So additive property of 0 is what? When you add 0 to the number, right? Whenever you are adding 0 to a number, you are getting the same number. That means identity is not changing. And so we say 0 is called the additive identity for whole numbers. Is it true for integers also? Yes. To any integer, if you add 0, then we also get the same integer. For example, if I add minus 3 and 0, I get the same result. Identity of the original integer is not changed in this case. So 0 is a universal additive identity. It is true for whole numbers, it is true for integers also.